switched neutral system can provide improved safety. A switched neutral system provides a clear demarcation between the line and load sides of the electrical system, reducing the risk of shock and electrocution if a fault occurs. Switched neutrals can offer reduced voltage drop. By isolating the neutral from the line side, the voltage drop experienced on the load side is minimized, improving the efficiency and performance of equipment. Enhanced stability is another advantage. A separately derived system is less susceptible to voltage fluctuations and disturbances from other loads on the electrical grid, providing a more stable power supply. Isolation of loads is beneficial. A switched neutral allows for the isolation of different loads or circuits, making it easier to troubleshoot and repair problems. Reduced electromagnetic field emissions are possible. By separating the neutral from the ground, the electromagnetic fields emitted by the system are reduced, improving electromagnetic compatibility. However, there are disadvantages. Firstly, increased complexity is a factor. Creating a separately derived system involves additional wiring, components, and labor, increasing the cost and complexity of the electrical installation. Secondly, there is the potential for miswiring. If a switched neutral system is not properly installed or maintained, there is a risk of miswiring, which can create safety hazards. Thirdly, increased maintenance is required. A switched neutral system may require additional maintenance and inspections to ensure its proper operation and safety. Switched neutrals are typically used in commercial and industrial settings such as hospitals and medical facilities, data centers and telecommunication systems, industrial control systems, and sensitive equipment and applications. Reasons for using switched neutrals include instances where improved safety and reliability are paramount, such as in healthcare or data center environments. When voltage stability is critical for sensitive equipment or processes. When isolation of circuits is desired for troubleshooting or maintenance purposes. Also, when electromagnetic interference is a concern and reducing electromagnetic field emissions is important. Overall, while a switched neutral system adds complexity and cost, it provides significant advantages in terms of safety, stability, and isolation. It is recommended for critical applications where these factors are of high importance.